Hi guys, I'm going to quickly go over the stuff you need to know for the Geologic timescale quiz, which will be on the Tuesday after Thanksgiving break. So the first thing you need to know is the law of superposition, which says that the oldest rock layers are on the bottom, like A here in this picture, and then the youngest rock layers are on the top, just like C here. If we had more rock layers, then whichever one is on top was deposited most recently, so it's the youngest. Whichever one's on the bottom was deposited the longest time ago, so it's the oldest rock layer. Same goes for fossils. If we had a fossil in this rock layer, we would know that it's older than a fossil that we found in this rock layer, okay? So that's the law of superposition. But sometimes rock layers are not always perfectly horizontal like this. Sometimes they get messed up by earthquakes or faults or something. So if they are originally put down horizontally, and if they are original, like horizontal like they should be, then it'll be the law of superposition. Oldest at the bottom, youngest on top. But sometimes they get tilted by earthquakes and plate tectonics and stuff. So here's an example of that. This is an unconformity. What happened was these rock layers down here were originally horizontal, just like this picture back here, but some kind of earthquake or just the tectonic plates shifting or something caused these layers to tilt so that they're diagonal instead of horizontal. Then wind and water and stuff weathered and eroded away this top layer. So it was all jaggedy, just like that video we saw in class, but then it got weathered and eroded away, so it was somewhat flat on top. Then another rock layer got deposited horizontally on top, because it's normal for rock layers to be deposited horizontally. So this is called an unconformity, because they were horizontal, they got tilted by an earthquake or something, and then weathered away up here, and then we got another rock layer deposited on top, okay? So make sure you understand how that happens. Make sure you understand which rock type can have fossils. That's sedimentary, because if an igneous rock had fossils, remember igneous rocks are melted magma that cools, that would destroy the thing that's going to get fossilized, right? Same with metamorphic. The intense heat and pressure would probably destroy the dead thing before it got fossilized. So sedimentary is what can preserve fossils, okay? You also need to understand intrusions. I've got a picture here of that. So a lot of the times magma from the mantle can come to the surface through volcanoes. It doesn't always make it all the way to the surface though. Sometimes it starts intruding or sneaking up through those layers. It doesn't make it all the way, and then it cools that into igneous rock, right? Cooled magma. So this is an igneous intrusion. So is this. You can see that it's got a little bubble here. That's still an igneous intrusion because it's cooled. It's magma that cooled inside the Earth's crust, okay? Someday, these layers up here probably would weather and erode away, and it might expose the igneous intrusion, right? But you need to know intrusions form because magma starts going up into the layers of rock, doesn't make it all the way to the surface like a volcano does, and instead it cools still inside those rock layers into an igneous intrusion, okay? Let's see. Oh, you also need to know about index fossils. Seems a little tricky at first, but it's actually pretty simple. So take a look, ignore all the words on this paper, just take a look at these pictures here. We've got four, it's calling them outcrops, but it's just four places that have rock layers. And each of these rock layers has some fossils. You'll notice that this fossil here is a brachiopod. Yeah, so that brachiopod fossil appears lots of times, right? Brachiopods probably lived for a long enough time that they were able to fossilize in lots of different layers. A lot of these fossils show up in lots of layers, but you see that this fossil here, this shell fossil, only occurs in one layer in all of these places. So I'm going to highlight that really fast so you can see a little bit better. That shell fossil would be an index fossil because, for example, if we knew that this fossil here is like 50 million years old, then in this other place we find the same fossil, we know that this one is probably around 50 million years old as well. Same with all of these. Now this can also happen even if they don't line up when you put them next to each other. Let me show you what I mean in this picture here. Again, just ignore all the words, but these are rock layers found in 3 different places. They look a little bit confusing, but don't get confused by them. Just look for the fossils that are the same in each place, okay? And I'm going to highlight which ones are the same. It's actually trilobite fossils. Trilobites are really good index fossils. Okay, so I've highlighted all of the trilobites in these 3 places. You can see that they're not, so here they're lined up, this one's not lined up, but however old these 2 are, could be 200 million years, could be 300 million years, that would be how old this one is, because index fossils, even if they're found in different places, they can tell us how old those rock layers are. So let's say this one is 200 million years old, then we find in a different place the same trilobite fossil, and also in this place we know that these 2 places is also probably about 200 million years old. So if we didn't know the age of these rock layers, we could find out based on index fossils. They're like a bookmark that like save our place in the rock layer so we know how old the layers are, okay? And then the last thing you need to know is even a million years ago, we still had tectonic plates moving, we still had earthquakes, we still had volcanoes, we still had fossils forming. All of that stuff happened according to the same rules in the past, a million years ago, as it does today, okay? So hopefully that was helpful. I want you to be successful in your quiz. Please ask me if you have other questions, and good luck on the quiz.